Welcome to Ancient Academy, the home of engineering and science.
Good day, everyone. Today we shall continue from our previous class. We have looked at various laws of indices. And we mentioned about 8 laws of indices. Before we start, let's list out these laws. Please follow up and listen attentively. So let's start with a very simple question from the first law. Now let's say supposing we have a base. Let's use a base 2 raised to the power of 3 multiplying a base 2 raised to the power of 1. Okay, and you're asked to simplify. You're asked to this is base 2 raised to the power of 3 and base 2 raised to the power of 1, and you are asked to simplify. So looking at it, this is very simple and straightforward. If we look at our first law, from the first law, we are told that we have a base x raised to the power of a times x raised to the power of b. That we should do what? Add the powers. So this will be equals to x raised to the power of a plus b. Okay. So from our question here, we have 2 raised to the power of 3 times 2 raised to the power of 1. So this simply means that we are having same base. So from our first law, it means that we bring out the base, same base, and we add the powers. So this is 3 plus 1. So this will be equal to 2 raised to the power of 3 plus 1 is 4. And we know that 2 raised to the power of 4 2 raised to the power of 4 is equal to 2 times 2 times 2 times 2. And this is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So it means that our answer for this is what? 16. As simple as that. So let's look at another example. Example 2. Let's say we have a different base. Okay, simplify. We have a different base. Let's say base 3 raised to the power of 4. Okay, and we are dividing with base 3 raised to the power of 1. Okay, let's say 2. And you are asked to simplify. So this will be equal to solution. This is base. Okay. Now if you look at it, this is division. 3 raised to the power of 4 divided by 3 raised to the power of 2. This we can find this from our second law, the division law. Okay. And the division law says that whenever you have a base and 2 bases having different powers and they are divided, you should do what? Subtract the powers. So from this you can see that we have same base while they are having different powers, and there is one division, so we are dividing the power. So from the second law, you can say that 3 raised to the power of 4 divided by 3 raised to the power of 2 is equal to 3 raised to the power of 4 minus 2. And this is equal to what? 3 raised to the power of 4 minus 2 is what? 2. Right? So this is it. And we know that 3 raised to the power of 2 is equal to what? 3 times 3. And 3 times 3 is what? 9. So it means that 3 raised to the power of 4 divided by 3 raised to the power of 2 is equal to what? 3 raised to the power of 2. And 3 squared is equal to what? 9. Okay. Let's look at a different example. From now we a bit fast because we have more complex questions to look at. So example 3. Simplify. Let's see, 2 raised to the power of 3 in bracket raised to the power of 4. Okay. Or let's see, bracket raised to the power of 2. Solution. So if we look at this, from our third law, from the third law, which is the power law, okay, it states that whenever you have a base, the third law, whenever you have a base, raise to the power of a different index, and all in bracket raise to the power of another index. It says that you should multiply the inner index and the outer index. So from the third law, you can see that we have 2 raised to the power of 3 raised to the power of 2. Okay? So it means that this will be equal to 2 raised to the power of what? 3 times 2. And this is equal to 2 raised to the power of 3 times 2 is 6. So it means that this is equal to 2 raised to the power of 6. And we know that 2 raised to the power of 6 is equal to what? 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Okay? So this will be equal to 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So it means our final answer is what? 64. Okay? Let's move to the next. Move to the next question. The next question we'll be taking a question from the fourth law. Let's take our question from the fourth law. The fourth law is the power product law. The power product law. Okay. And from the power product law, we can see that supposing we have two different bits raised to the same power. Okay. We have 2 different bits raised to the same power. Okay, let's look at what that would be. So, example 4. Simplify. Okay, let's use 2 and 3 as our base. Okay, 2 times 3 raised to the power of the base. The base. Okay, let's use 4. 2 times 3 raised to the power of 4. Okay. So from the fourth law, we can see that 2, that is 2 dot 3. The dot here representing times, okay? 2 dot 3 raised to the power of 4. Now in this question, I'll show you something. Now this is for the purpose of indices. That is why you see we are putting 2 dots. 2 dot 3 raised to the power of 4. Now 2 dot 3 is simply the same thing as 2 dot 3. Okay, raised to the power of 4. It's simply the same thing as 2 times 3 raised to the power of 4. Okay, so there's no point getting confused. And we know that 2 times 3 is 6. So you can decide to solve it. 2 times 3 is 6 raised to the power of 4. You still have the same answer. But for the purpose of this class, we are trying to see how to apply this law in our everyday life. Okay, so that's why we are just putting 2 times 3 raised to the power of 4. So from the fourth lesson, whenever you have 2 different bases and they are raised to same power, having same index, okay, you use each of the base raised to the power of that index. So in this case, since we have 2 times 3 raised to the power of 4, it means that this will be equal to 2 raised to the power of 4 times 3 raised to the power of 4. Okay. Remember I said that the dots represent time, so it means we can say this is equal to 2 raised to the power of 4 times 3 raised to the power of 4. Right? And we know that 2 raised to the power of 4 is what? 2 times 2 times 2 times 2. And this is what? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Right? And 3 raised to the power of 4 is what? 3 times 3 times 3 times 3. And this will be equal to 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81, right? Now, so it means that 2 raised to the power of 4 times 3 raised to the power of 4 can be written as 16 times 81. Okay? Which is equal to 16 times 81. That means, let's use a calculator. 16 times 81 is 1296. 1296. Okay, so that is for that. Now quickly let's look at next example 5. Now example 5, we apply the zeroth law. Okay, so the zeroth law is very simple. Let's say simplify any figure. Let me use 100. Okay, raised to the power of what? 0. Now from the zeroth law, we have seen that whatever, irrespective of the base, raised to the power of 0, we see that it is equal to what? 1. So from the fifth law, 100 raised to the power of 0 is equal to 1. So similarly to any base, if this 100 was 1000, raised to the power of 0 to be what? 1. If this 100 was 1, raised to the power of 0 to be what? 1. So irrespective of the base, whenever it is being raised to the power of 0, our answer is 1. Let's quickly look at the next question. Okay, that is the sixth law, and the sixth law is the negative index. The negative index, it means that we are having a negative index. We have a base, let's take power of negative, a negative index, and we are told that whenever our base is raised to the power of a negative index, it simply means that we take the reciprocal of the base raised to that power. Okay, as simple as that, we just take the reciprocal, that is 1 all over the base raised to the positive power. So that is, this is example 6. Okay, so let's say we have a base. Let's use 2. Simplify. I'm just using 2 because it is very simple to simplify. I will get a better understanding using that. So let's say simplify 2 raised to the power of minus 4. Okay. Now you can see that we have a negative index. The index is our power, okay, our exponent, and the negative index is what? Minus 4. Okay. So we are asked to simplify that. Now we know that from the sixth law, we have been told that whenever you have a base raised to the power of negative index, you take the reciprocal of that base raised to the power of the positive index. Okay, so we are doing that. In this case, our base is what? 2. We have a negative sign representing a negative index. Our index is 4. Okay, so from the sixth law, it means that 2 raised to the power of minus 4 is equal to what? 1 all over 2 raised to the power of 4. Okay, now this will be equal to 1 all over. We know that 2 raised to the power of 4 is what? 2 times 2 times 2 times 2. Right? And it simply means that 2 raised to the power of minus 4 is equal to what? 1 all over 2 times 2 is 4, 4 times 6 is 8, 8 times 2 is what? 16. Okay. So it means that our answer is 1 all over 16. And let's quick